And welcome to a real quick video on everybody's favorite math strand, patterning in algebra, where today we are going to be looking at, using our wonderful light board here at St. Joe's, how to solve a pattern rule based on a growing pattern that you can see here. So the idea, the learning goal, is to try and get you to look at this and try to determine what things are changing and what things are staying the same, and then establish a mathematical expression or an algebraic expression that will help you find the nth term for this. So let's get started and let's see what we're dealing with here. So what we have here is we have a pattern. We have the first picture, we've got 2 greens and 3 pinks. The second term, we've got 2 greens and 1, 2, 3, 4, 5, 6 pinks. And then in the third term, we have 2 greens and 1, 2, 3, 4, 5, 6, 7, 8, 9 pinks. Now, it doesn't take a genius to figure out that the pinks are growing and the greens are staying the same. I'm going to throw some mathematical words at you right now, some mathematical vocabulary. The greens are staying the same, so we like to call those constant. And the pinks are changing, so we're going to call those variables. Now, what I'm about to do is I'm about to create a table of values. Is it necessary for you to do? I don't think so, but I like to do it just because it helps me kind of organize the information a little bit better if I'm not working with some pictures. So let's take a look. So the first thing I want to do is I want to look at what term I'm working with. So in the first term, so the first picture, that's the first picture, I have a value of pinks plus greens all together. So the value is everything together. 3 pinks and 2 greens is 5. And then if you look at the second term, or the second picture, I've got 6 pinks and 2 greens, which is 8. And then if you look at the next one, I've got 9 pinks and 2 greens, which gives me 11. All right, perfect. So now that I have that organized, let me take a look at this. I see a 5, I see 8, I see 11. Well, I can see mathematically that that is growing by 3 each time. And I'm going to switch to pink here because the pink is the one that's growing. The greens are staying the same. So I'm going to go plus 3, and then this is plus 3 as well. Now, that is constantly growing by 3 every term. So if I add a term, I add 3. If I add a term, I add 3. If I add a term, I add 3, so on and so forth. And consequently, if I subtract a term, I'm taking 3 away. So I'm going to use that plus 3 as the start of my expression, because that's kind of what it is. It's a constant. So I'm going to start with 3n. 3 times the term. Every term, I'm adding 3. Add 3, add 3, add 3, add 3, or take 3 away, so on and so forth. And then I'm left with, well, what about these green guys down here? What do I do with them? Well, they're part of the expression because I counted them as part of the value. So how do I make that work? Well, mathematically, if I look at this expression here, 3 times term number 1 would give me 3. But I'm not looking for 3, I'm looking for 5. How do I get 3 to equal 5? Oh, it's because I forgot these 2 guys over here. So I want to add 2 to my term number, and I'm going to put those in green to represent those 2 little sticks that don't change. So now let's see if this works here. If I take a look at 3n and I multiply 3n times the second term, so 3 times the second term, the second picture, every time the term grows, I add 3. 3 times 2 is 6. 1, 2, 3, 4, 5, 6. Plus 2 gives me 8. So I know that that mathematical expression worked for that and that. Let's check the next one. If I take 3 and multiply it by the third term, you can see I've got 3 triangles. There's a triangle. That's a term. Here's a triangle. That's a term. Here's a triangle. That's a term. So I've got 3 triangles. 3 triangles times my expression. So 3 times 3 is 9. So let's actually write this out here so you can see what this looks like. I would go 3 times 3 plus 2. Now 3 times 3 is 9 plus, and I'm switch back here to make sure I don't forget these little constants. 3 times 3 is 9 plus 2 would be 11. And if you look here, that 11 would be exactly what this is. The 11 and the 3. They go together. Now, how would this work if I wanted to do something that was, I don't know, in a negative term? Would it change something? Well, let's take a look. Now that I have this expression and I know that this expression works, let's see if I can plug in a negative number and see if that works. So let's try negative 2. So I'll go here and go negative 2. And then if I'm going to write it right here so hopefully you guys can see it. If I just plug in the number 3 times negative 2 plus my 2 little constants there. I don't want to ever forget those guys. Those are kind of important. 3 times negative 2 plus 2. Well, 3 times negative 2 and negative times a positive, I know that that equals a negative number, so I know it's going to be negative 6. And then I'm going to add my 2 constants to it. And I end up with negative 6 plus 2, which gives me negative 4. So this value right here goes there, negative 4. So I know the negative second term is going to have a value of negative 4.